Feedwater flow control. It comes under boiler control system. Feedwater flow control. The purpose of the feedwater flow control is to supply feedwater to the boiler to make up for the steam supplied to the turbine. In drum type boilers, the feedwater flow is regulated to maintain the boiler drum level at a preset level. Any deviation of the drum level from the set point is an indication that the supply of feedwater to the boiler and the steam flow from the boiler to the turbine are out of balance, and a change in feedwater flow is necessary to restore the balance. Single element control system. A feedwater flow control system that regulates the boiler feedwater flow by utilizing only the steam drum level is called a single element control system. Single element control is adequate for small boilers. Request. It is hoped that this session is going to be useful to you. Please press like. Please subscribe. Shrink and swell effect. However, with large boilers, drum level is not a good indication of whether the steam and feedwater flows are in balance because of the shrink and swell effect in the steam drum during load changes. Shrink. On decreasing load, closing the turbine valves causes the steam in the steam line to back up to the drum, resulting in a pressure increase which reduces the size of the steam bubbles in the steam generating tubes and shrinks the drum level. Swell. Conversely, on load increase, the opening of the turbine valves produces a drop in drum pressure and causes the water in the generating tubes to flash into steam. The steam bubbles produced serve to swell the drum level. In either case, the ensuing level deviation misleads the control system to change the feedwater flow in the wrong direction. The remedy for this is a 3-element system, with the 3 elements being feedwater flow, steam flow and drum level. The figure is in the next slide. This diagram shows the 3-element boiler drum level control system in detail. We shall be referring this diagram in the subsequent slides. But however, whenever you want, you can always come back to this detailed diagram for your reference. This system is basically a cascade plus feed forward control loop. Steam flow is used as the feed forward signal, which is summed with the drum level control signal and becomes the demand for feedwater flow. In general, the turbine first stage pressure is used as the steam flow signal, and the feed water flow is measured at a point on the feed water line between the boiler feed water pump discharge and the economizer inlet. Feed water flow measurement typically is temperature compensated to account for the change in water density because of variations in temperature. The final control elements are the feedwater control valves installed in the feedwater line to the boiler for constant speed motor driven boiler feed pumps. Variable speed motor driven pumps are equipped with a hydraulic coupling with a scoop tube that is positioned by a drive unit to change the speed of the pump. With turbine driven boiler feed pumps, the turbine speed is varied by positioning the turbine control valves. A typical turbine drive has a high pressure and a low pressure steam chest, each equipped with a hydraulic type control valve. The two valves are operated in sequence. The low pressure valve opens first, taking extraction steam from the turbine. When the low pressure valve has reached the maximum position, the high pressure valve opens to admit additional steam to the turbine. The most common steam sources for the boiler feed pump turbines are the crossover steam to the low pressure valve and the main cold reheat or auxiliary steam to the high pressure valve. Request: it is hoped that this session was useful to you. Please press like. Please subscribe.